The universe is filled with spectacular objects. Blazing stars, glowing nebulae, entire galaxies shining across billions of light years. We can see them, study them, and photograph them. But how do you find something that is completely, perfectly invisible? An object that emits no light, no heat, no signal of its own. How do you hunt for a monster that lives in total darkness? Today, we're not talking about what black holes are, but the clever detective work we use to prove they exist. The first and most powerful clue that a black hole is nearby is gravity. You can't see a black hole, but you can see what its immense gravity does to everything around it. Imagine you're looking at a star. For years, you watch it, and you notice something strange. It's not moving in a straight line. It's moving in a circle, as if it's dancing with an invisible partner. By tracking the star's speed and the size of its orbit, astronomers can calculate the mass of its invisible partner. If that partner has the mass of millions of suns, but there's nothing there to see, you found a black hole. This is exactly what we see at the heart of our own Milky Way galaxy. We've watched stars for decades, whipping around an empty point in space at millions of kilometers per hour. They are dancing with the supermassive black hole at our galaxy's center, Sagittarius A star. Another clue uses light itself. Einstein taught us that massive objects don't just pull on things, they bend the very fabric of space and time. Think of light as a marble rolling in a straight line. When it passes by a massive object, it follows the curve in space-time. Its path gets bent. A black hole's gravity is so extreme that it acts like a cosmic magnifying glass. When a black hole passes in front of a distant star or galaxy, the light from that background object gets bent and magnified, sometimes appearing as multiple distorted images or a bright ring. This effect is called gravitational lensing. When we see light from the distant universe being warped in this specific way, it's a giant cosmic signpost pointing directly to a massive invisible object. While black holes themselves are black, their mealtimes are the brightest shows in the universe. When gas, dust, or even an entire star gets too close, it gets caught in the black hole's gravitational pull. But it doesn't just fall straight in. It gets whipped into a frenzy, forming a flat, spinning disk around the event horizon. This is called an accretion disk. The material in this disk spins so fast that friction heats it to millions of degrees, causing it to glow brighter than entire galaxies. It glows in visible light, and it screams in high-energy radiation like X-rays. So, when our X-ray telescopes detect a tiny spot in the sky, blasting out unbelievable amounts of energy, we know we're likely looking at the last scream of matter before it crosses the point of no return. We're not seeing the black hole, we're seeing the fire from its feast. The final piece of evidence is the most profound. It's not something we see, but something we feel. Einstein predicted that when truly massive objects, like two black holes, collide and merge, they create ripples in the fabric of space-time itself. These are gravitational waves. For a century, this was just a theory. But in 2015, observatories on Earth finally detected these faint ripples washing over us from a collision that happened over 1 billion years ago. We had felt the echo of two black holes becoming one. It was like hearing the sound of two ghosts colliding in a dark room. This discovery was so important, it won the Nobel Prize. So, how do we hunt for the invisible? We don't look for the monster itself. We look for the footprints it leaves behind. We watch the ghostly dance of orbiting stars. We see light bent by its gravity. We witness the bright scream of its cosmic meals, and we feel the faint ripples of its collisions across the universe. And in 2019, using all this knowledge, we finally took a picture. The first direct image of a black hole's shadow. Proof that the invisible monsters are real, and that even in total darkness, there are secrets waiting to be found. If you enjoyed this cosmic detective story,